Here we're going to rotate a curve about the y-axis, and we're asked for the area of the resulting surface. Our curve is x to the 2/3 plus y to the 2/3 is equal to 1. If we're rotating about the y-axis, then our surface area is an integral, say, from a to b of 2 pi x ds. Left out an important piece of information here. Y is going from 0 to 1. Ordinarily, when I see y goes from 0 to 1, I'm thinking I'm going to use a dy. But in this case, we're not going to. I'll tell you why after we do our work. We're going to go in terms of x, but I need to show you a picture of what this curve looks like. As you can see from the equation, x and y max out at 1. And because of the exponent 2/3, that's the immediate exponent, x and y could both be negative. What we end up with is something I believe is called an asteroid. And it looks like a square, but with mushed in sides. If we rotate, and we only have, we're considering only y, it goes from 0 to 1, so only the upper portion of this. But if we were to rotate the entire upper portion about the y-axis, then we're going to end up with a surface for the right edge over here and a surface for the left edge over here. They're going to overlap, but the point is we would get an answer that is twice as big as we need. So we're only going to consider the portion in the first quadrant. And for this, we have that x goes from 0 to 1. Having decided that we're going to do this using dx, again, my reasons will be clear later, we need to solve this equation for y. Y to the 2/3 will then be 1 minus x to the 2/3. Now I need an exponent of 1 on y, and so I need to raise everything to the 3/2 power. So I have y equals 1 minus x to the 2/3, that quantity to the 3/2 power, because if I were to take x to the 2/3 to the 3/2 power, I would get x to the first. The 2 in the denominator of the exponent indicates a square root. Ordinarily, I would need a plus or minus, but we've already been told that y will only be positive. We now need to take a derivative. So using the power rule, y prime is equal to 3/2 times the quantity of 1 minus x to the 2/3. Subtracting 1 from the exponent means that's going to be to the 1/2 power. And don't forget, we need to use the chain rule. The chain rule is going to give us a factor of negative 2/3 x to the negative 1/3. And we can see that the 3/2 and the 2/3 will offset each other. We know our formula involves a square root of 1 plus y prime squared. So we need to square this quantity. Before I do that, though, I'm going to express this as a fraction. So we have the square root of 1 minus x to the 2/3 divided by x to the 1/3, and there is a negative out front because of the negative in the derivative. Remember, a negative 1/3 exponent means a 1/3 exponent in the denominator. Squaring this and adding 1 will give us 1 plus 1 minus x to the 2/3 divided by x to the 2/3. Getting common denominators is going to give us x to the 2/3 plus 1 minus x to the 2/3 divided by x to the 2/3. And we can see that the x to the 2/3 in the numerator will subtract out. What we really needed, though, was the square root of all that. And so I'm ready to put this into our formula. A is going to be 2 pi times the integral from 0 to 1 of, now don't forget in our formula, we have x. So x times the square root of 1 over x to the 2/3, so 1 over x to the 1/3 dx. Now I'd like to point out how basic this integrand is. We're going to simplify here, use the power rule, it's all good. Let's go back up here before we finish that, though. Here we have an x in our integrand for the formula of rotating about the y-axis. the integral from a to b of 2 pi x ds. If we had done this in terms of y, like I maybe originally thought we were going to, then we would have to solve this equation for x. It would look very much like y equals 1 minus x to the 2/3 to the 3/2 power. X and y would interchange roles. But then when I go to, and we'd have to do all this derivative stuff. We'd have an expression that looks a lot like this. It would be 1 over y to the 1/3. But then for this x factor that's in the formula, we'd have to use the one that looks like this. And folks, that integration would be hideous. Go ahead and do it. I dare you. Well, I ain't going to do it. I'm going to do the one we have here. Except I need to make one change. I realize I wrote down a equals and it should be s equals. So we need to simplify the integrand. S is equal to 2 pi times the integral from 0 to 1 of x to the 2/3 dx. Using the power rule, we have that x is equal to 2 pi times, that's going to be 3/5 x to the 5/3 evaluated from 0 to 1. And quick arithmetic is going to give us x is equal to 6 pi over 5.